right, so that was my only point in that announcement that I made. Just let me know ahead of time that you're using a slip day before the deadline.
Preferably days before, not hours before.
You can let me know like a minute before. That's fine. Just so that once I download it, I know which ones I should be grading and which ones I should hold off on. That's fine. Just get an email to me before the deadline. All right. So any other questions or comments on anything? All right. Well, go ahead and send me an attendance note. And let's jump into ODP 415. So ODPs are back. So ODP 415, you're writing a function in C. The function is called calc. It takes an array of characters, so declare the argument as a char star, and it returns an int. And the main thing this function does is it does arithmetic. So if you pass a string containing the three characters 9 plus 9, your function should return 18, which is 9 plus 9. If you pass 9 asterisk 8, it should return 72, which is 9 times 8. So your expectation is you're going to get an integer, which could be positive or negative, right? But some sort of legal integer, followed by an operator, plus minus star slash, followed by another integer. And as long as that's exactly what you're seeing, an integer, an operator, and an integer, do the operation and return the sum. So for example, 121 plus 23456 should return 23577. If any of the integers that you pass is not a legal integer, though, you want to return -1. So this is a test, returns -1. 2.3, this is a test, returns -1. 2 plus haha returns -1 because haha is not an integer. But if you pass an integer followed by an operator other than one of these, followed by an integer, go ahead and return -2. So if you do 2 and a period and a 3, that should return a -2, right? 2 is an integer, 3 is an integer, period is not a legal operator. If you did a 9 equals sign 8, that's an integer, but that's equal sign is not a legal operator, so return a -2. All right, so that's your calc function. Write that, test it with your own main program. And then when you're pretty sure it's working, go ahead and link it with the test bed, ODP 415 main.o/temp, and then assess your executable. And there's almost no real hard work to do in this if you use scanf, right? And you can parse the string with %d, %c, %d. So let's see what scanf does for a pattern like that. And remember, scanf is a great function to use anytime you're dealing with integers. Anytime you want to know, is something an integer, or you want to have a string that includes integers, think scanf. So what does this look like? Suppose your string is something like 23 plus 11. And we're doing an scanf string, and then %d, %c, %d. And I'm going to scan into 3 variables, num1, op, and num2, and I'm going to declare these as integers for num1. Sorry?
Your terminal is in the way.
Okay.
Being able to see on your paper.
Thank you. I'm going to declare these as integers for num1 and num2, and op is going to be a character. Just a character, not a character star. Char star means it's a string, but we're scanning with a %C, not a %S, so that's just going to be a single character. And because it's a character, we're going to need the ampersand in front of the variable name. All right. These are details you can take from here and get 100% on the ODP, but make sure you understand what's going on here, right? Why do I need an ampersand there? Normally when we have a character variable, we don't put the ampersand. Well, that's when we have a character array, like a char star op or a char op bracket 120, then we skip the ampersand. But if it's a single character, it's just like a single integer, right? We put the ampersand in front. And we know it's a single character because we're doing a %C instead of a %S. So this right here is, you know, several concepts in play, and you want to make sure that you're really clear on each of those aspects of using this version of scanf, because it'll help with, you know, everything else we do with strings. All right, so I'm going to save this into an integer. I'm going to call it ret. And what's the value of ret going to be? If ret is 1, it means we found an integer, but we didn't find a character after it, right? So that's missing an operator. If ret is 2, we found an integer, an operator, but we didn't find a second integer. If ret is 3, we found exactly, you know, integer, character, integer. So that's a good case. If ret is 0, we didn't find an integer in the beginning. If ret is -1, your string is empty. So all of these are error cases. And so this is what you want to check for. So we could say something like if ret is not equal to 3.
How many arguments can you give scanf before you get problems?
More or less unlimited.
Really?
Yeah, I mean it's a function of stack space, which is, you know, many megabytes. So you probably won't run into a limit. You'll run into a problem trying to match up your commas before the CPU runs into a problem.
What do you mean stack based?
So when you call a function, the arguments are pushed into an area of memory called a stack. And the more arguments you have, the more things have to get saved in that area. And I think it's only when you run out of space in that area that you would have hit, you know, a too many arguments kind of error. And it's pretty hard to run out of stack space unless you're doing something very deliberate, like recursion or a fork bomb or something. So pretty much no practical limit to how many arguments.
Is there a way that I can trap the function such that I can have essentially unlimited arguments like that?
Yeah, so there's a thing called varargs. Maybe I'll talk about that later in this course, but there's a way to specify in your function declaration, you can put in a ... And that basically says, I don't know how many arguments I'm going to get. It's variable. But if you look at standard io.h, this is an example of a declaration using varargs. So it's you know, this is fprintf, it returns an integer, it takes a file pointer, it takes a character array, and then takes 0 or more additional arguments. And there's language elements that let you pick up those arguments and use them. So you can write your own functions with a variable argument length. And you could write a C program to generate, you know, an scanf statement with 1,000 variables here and see if it'll compile. And I'm pretty sure it will. But that would be a fun experiment, test the limits of that. Alright, so if return is not equal to exactly 3, then you want to return a -1. And the description of the ODP actually says, right, if you cannot parse the string successfully using this pattern, return a -1. That's all you need to know about that syntax error. Call scanf, use this pattern. Parsing it successfully means it returns exactly 3. If it doesn't return 3, just return -1, and you're done. If it does parse successfully, then what do you have? You have a number stored in num1, a number stored in num2, and an operator stored in OP. And so if OP is equal to plus, then you want to return the sum of your arguments, num1 plus num2. If the operator is equal to minus, then you want to return num1 minus num2, and so on. If it's not equal to any of those, that's an error, and in that case, error with the argument, you want to return -2. So scanf will do most of the work for you. Do your scan, make sure that you parsed successfully, and if you did, check which operator you have. If it's an operator that you know about, go ahead and do the operation and return it, otherwise return -2. So questions about that?
So does that mean you have to manually, because there's no way to put an operator into, like, use a variable as an operator?
No, we can't say like num1 operator num2, but it's going to be 4 if statements, or if you like switch statements, it works really well as a switch, because this is basically an integer, so you could do a switch, case plus, case minus, and then for your otherwise you could throw the error. But good opportunity to get good with VI, right? Because this is going to be, you know, the same statement 4 times, except your plus is going to become a minus, your plus will become a minus, right? And so good exercise in moving around in VI. If you come over to this plus sign, you can hit a J to go down here, and then just do a lowercase r minus, that'll replace the plus with a minus. Do W a few times to get over to this plus sign, do an R minus, right? And then do a J to go down to your third copy and do an R asterisk, and then go back to do an R asterisk here. I mean, you can play around with it, but think of it as a kind of lame video game, right? How can you do these operations as efficiently as possible? Alright, so any other questions about the ODP? And if you came in late, go ahead.
I might have missed it, but I'll still ask. What's the difference between char star and char star star?
And char without a star, maybe. So char star says that S is pointing to a character. So S is a location in memory where presumably we have a series of characters stored. So it's a string. If we say char S, it's just a character. It's like an int or a double. It's a single location in memory. And in that location, we would find, a character stored. If you say char star star S, it says S is pointing to some location in memory, and that location is pointing to some other location in memory, and at that location we find a string. So char star star is saying S is a pointer to a char star, which is a pointer to an array of strings, or a pointer to a character which begins an array of characters. And I have in my notes to play around with this char star star in GDB today if we have time. And that will make it look horrifying but clearer. when we do that. All right, and if you came in late, we talked about slip days in the beginning, so I sent an announcement yesterday asking you if you're planning to use a slip day, please send me an email to my usual direct email address before the deadline for an assignment. So you can use slip days for PA4 and PA5 still, right? So if, you know, the assignment is due Friday morning at 8 and you plan to use a slip day, you got to tell me before Friday morning at 8, okay? I don't care if it's, you know, 2 minutes before the deadline. Just let me know before the deadline, because once the deadline hits, I download assignments and I move them somewhere and I plan to start grading them. And I don't want to grade somebody's assignment, give them a grade, and then have them say, oh no, I'm going to use a slip day, and so on. So if you're not going to make the deadline, just tell me ahead of time. Okay, if I haven't gotten a notice from you by the deadline, I'll go ahead and grade it as being submitted without slip days. And if, you know, it's due Friday morning, you send me a note Friday at 7:30 and say I'm going to use a slip day, fine, I'll download it Saturday morning at 8. If Saturday morning, you know, at 2 a.m. you say I'm going to need another slip day, send me another email, right? And then Saturday morning at 8 I won't download. Basically, I download every morning at 8 o'clock starting Friday. And I grade the ones, you know, for which there's no slip day or the slip days have been used. All right, so let's talk about a few more Unix utilities. So I want to talk about char and I want to talk about gzip. And these are not terribly mysterious. So let me find an area to play with. Well, that won't work. Alright, so here's a directory I have. Let me make a work directory under here. Alright, so I'm just making a workspace here, so I've got my CSE224 directory. I have a couple of subdirectories under here, PA2 and PA3. PA2 has a README, PA3 has, you know, my stuff for the high-low game, and it's got a work directory, and so on. So sometimes it's nice to be able to take a bunch of files and turn them into a single file, something like a zip file. All right. There's a standard command in Unix for doing that. The command is char, which is short for tape archive. And char will let us take an entire directory tree and copy it into a single file. And then we can take that file, we can, you know, put it on a flash drive, we can copy it somewhere else, we can make multiple copies of it, and at some point, if we want, we can untar, which will create a new directory tree based on the contents of that file. And tar is, you know, a wild and wonderful command with lots of options and switches and ways to modify its behavior and so on. There's only 3 tar commands I've ever had to use, right? So I'll give you those, and those will work probably for most of what you want to do, but you know, as usual, you can go on the manual pages and find other options and so on. So the first tar command is cvf. And this is how we create a tape archive, a tar file. And it's a little different from most other commands. There's no dash in front of here. You know, I just threw one by mistake. So tar cvf. All right. This next part is really critical. This is file to create. And this has got to be the next thing after CVF. Whatever you name here is going to be destroyed and replaced with a tape archive. So don't put the name of your good program that you're planning to submit, right? This is the file you want to create. This is the name of the tape archive. And this is followed by files to add to the tar file. And so this creates a tar file. So for example, let's say I'm here in my PA3 directory and I want to make an archive of all of this. I'm going to say tar cvf backup.tar, and it's going to say asterisk. And it's going to show me each file that gets added to this backup. So there's my files in this directory. There's the subdirectory work, and there's the two files in my subdirectory named work. And I've asked it to create something called backup.tar. So if I do an ls, now I have a backup.tar file. And it's, contains all the stuff in this directory tree, so these can get pretty big. And if you try to VI it, it's not human readable. You don't want to edit this file, right? So I VI'd it by mistake, just :Q to get out. Don't save it, right? But that creates the archive. And I can put that on a flash drive, like I say. I could probably email it to myself. I can save it in another file, another directory, whatever. All right, so that creates an archive. The next command is to look at the contents of an archive, and that's tar tbf and tar file name.
Can you move your command line, please?
Oh, for the old one. There you go. So tar tbf tar file name. This is the tar file name. This is to show the contents. Alright, so tar tbf backup.tar, and it shows me what's inside this tar file. So here's my files that were saved. Here's a directory named work. Here's the files inside that work subdirectory. And it preserves, the file owner, the group owner, the permission bits, the size, the creation or modification time. All that information is saved. And then your last command is to extract the files from a tar archive. So you can say tar xvf and the tar file name. And that will make a copy of the directory tree that's stored inside this tar file. So for example, I could say maker new test, and I could copy backup.tar to that directory. So if I go under new test, right, this is a totally different directory now. There's nothing in here except this backup file that I just copied into here. But if I say tar xvf backup.tar, now I've got my whole directory tree restored in here. Right, I'm still in this new test area, but I've got all of my files, and I've got my subdirectory work, and it's got its files, and so on and so forth. So this is a really easy way to sort of capture like your entire directory tree, and as you're working on bigger projects and you're breaking things into pieces, making multiple files with different functions and so on, right? And eventually, you start making subdirectories to have different pieces of your project. This is a nice way to sort of capture it all into one file, and then you can untar it somewhere else. And if something happens, if you lose, your work, and you've got a copy of this backup, you can always reproduce your work. All right, so create, list the table of contents, and extract. And the only one you have to be really careful with is this: make sure the argument after CVF is the name of the tar file you want to create. And if you just say tar cvf *.c, you're going to clobber one of your .c files. Because the first .c file is going to be taken as the name of the archive to create, and it's going to get overwritten with a tar file. And you'll end up losing the source code. But this is nice now because, you know, I've got one file and I could SFTP that to another machine, and then make a clone. And you know, you can go into your main CSE224 directory and make an archive of everything, right? And now all.tar has you know, my PA2 directory, my PA3 directory, all the stuff underneath PA3 like work and so on and so forth. And if you want, you know, if you do this from your home directory, this will make an archive of everything in your home directory tree, right? Basically every file that you have, all the way down. But it will get big really fast, right? So don't do this unless you're planning to do something with that archive and then delete it, because we don't want to run out of space. But you know, if you're on the Linux server and you've got a big you've got all your work and you want to copy it somewhere else, that's one way to do it. And it'll basically give you a single file you can just move around. Alright, any questions about that? Alright, and then gzip is... Go ahead.
So the tar command just copies them into there, right?
Yeah, it does not delete them, it just makes a copy.
Okay, cool.
But if I do an xvf and I have files sitting in here already, those files will get overwritten when I extract them from the tar. So usually you do xvf in a different directory, and you're trying to make a copy of your directory tree.
Okay.
Alright, and then the other command is gzip, and gzip is basically just like plain old zip. And it's used to compress a file. So let's go back in here. So my archive is 51K. I can say gzip all.tar, and now I've got a compressed version that's only 8K, so it's, you know, less than a fifth the size of the original. And if I want to, and it gets a .gz extension. If I want to unzip it, I can just unzip and get back to my original file. So if I was doing this on the Linux server, for example, what should I do here? Let's just make a file called my tools.tar, and I'll just put all of my tool stuff into there. So what I've done on the Linux server is I've created an archive that contains all the stuff under my tools directory, right? So including my Git information, because some of this is under Git control, so that gets included, and my utilities for making new student accounts and that kind of stuff. So here's a really good file, tools.tar, that I'd like to save on my local laptop, right? So how do I do that? Well, let's go to wherever I want to save this. Let's say I want to put it right here. So I can do SFTP username at linuxengrcs.com, And I can use this to pull files. So for example, if I say ls, it'll show me the files on the remote machine. There's my tools.tar. I can say get tools.tar. It'll fetch it. And now if I look in my local directory, there's my file I just copied from the Linux server. So SFTP is a nice command line tool. You can say SFTP username @ machine. It will log you in. It'll ask you for a password if you don't have a key pair set up. And then you can run commands like ls, cd, etc. to move around on the remote machine. Then you can say get to pull a file down. You can also say put to push a file up. If you're on Windows, you can run something like WinSCP, and it's a drag and drop version of SFTP that lets you move files around from the Linux machine, in this case, to your local system.
So that just copies it to the file that you did the SFTP.
Mm-hmm.
Yeah.
Yeah, so
And how does the push work?
So here's an ls. Let me make a file. All right. So here's what my account looks like on the Linux server. If I say put new file, it'll just say uploading new file to, and there's the directory it's going into on the Linux machine. And so now on the Linux machine, if I look, there's my new file that I just pushed over.
Oh, okay. Very cool.
So mostly you log in, you say put and get, but you can do lots of other things. For example, I can say let's do a local ls. This will do an ls on my local machine. I can say ls to look at the remote machine. I can remove files from the remote machine by saying rm. I can do a cd on the remote machine, so I could say cd into tools. And so now on the remote machine, I'm in the tools subdirectory. I can do an ls on there. I can go into my QA directory and do an ls there, and so on. And you can also do local versions, so I could say local print working directory, local current directory, .. local ls, and so on. And there's a help inside that's pretty concise, but tells you most of what you need. And you know, you can change file modes and permission bits and all kinds of stuff. When you take a system programming course at university, you get to write this command yourself. It's a fun assignment. All right, gzip. Other command I want to mention is just find. Find's a useful little widget to know. And again, it has a gazillion options. A big long manual page. But the easiest way to use find, if you're sitting in some directory, you can just say find period. And it will say find all the files starting at this directory. Remember, period is an abbreviation for your current directory. So if I want to see every file under my current directory, I can just say find dot, and it lists all the files. And so if I go into my home directory and I say find dot, that'll list every file on my system. But the way I usually end up using find is find directory you want to search from, -name, and then in double quotes you can list the name with wildcards. So if I want to find, say, every PDF file on my system, I could say find .-name star PDF, and it'll list off all the PDFs. and it's fast, right? I've got, you know, a few terabytes of disk space here, most of a terabyte in use, and it's really fast. And things are indexed and so on. So that's a useful command to know. All right, quick note on winter terms. So I put out a survey a few days ago, and I got responses from about 80% of the class, and it sounds like only a small number of people, like about 15%, are extremely interested in the in-person class. Most are either agnostic or prefer remote. So we're probably going to cap enrollment for the in-person class at 25, and that's probably going to be a strict cap because of spacing. So if you really need to do the in-person class, or you really want to do the in-person class, make sure you register as soon as your registration opens, right? Like set the alarm clock and wake up and register for whatever section you want for all of your classes, but definitely for 222 in winter. And after 25, then everybody's going to have to be in the remote section. So, and like I say, it sounds like only about 15% of the students, you know, about 8 students, I think, across the 2 sections expressed that they wanted to be in the in-person section.
I have a question.
Yeah.
Will CSE215 be available over the summer at all?
No, CSE215 is only in fall and winter, and for winter it's only going to be available in person, because it's online in fall. And
So
again, it
there's only
sounds
25
like,
people left.
sorry?
So, winter, there's only 25 people that'll be able to take the class in the winter.
I'm planning to overload it as necessary, but from the people who are in 222, or in 224 right now, which is where I sent out the survey, total number of people who are planning to take 215 was only 19, so 25 should fit easily.
And you did say there's no online version?
There's no online version for 215. That's only going to be face-to-face because it's only a single section.
Okay.
But I will overload that as necessary. The challenge, though, is that if we get above 25 people, we may not be able to fit more than 25 people in the room, so we may have to overflow and have people, you know, do it kind of remote in person or something like that. So we'll see. And there were 3 people in the section who said they needed more information to answer the question about 215. So if you're not sure whether you're going to take 215 or whether you need it, definitely send me an email. All right, that's a great email question.
I sent you an email on that like 2 weeks ago. Yeah, it's not part of this one.
Oh, really?
Yes.
Did you send it to nmacias@clark.edu?
Yes.
Huh. Okay. Can I ask you to send it again, because I don't have any emails outstanding, and so it must have gotten lost.
Alright, I just forwarded it to you again.
Okay. Thank you. All right. Well, presumably that'll show up at some point. There we go.
It's got a lot more questions other than just CSE215, so you can look at them.
Okay, cool. I will take care of that after class. All right, and for others, if you're not sure about CSE215, right? Basically, if you're planning to transfer to WSUV in fall, you need to have CSE215 or the equivalent from another school. So if you're not taking it in fall, you're going to have to take it this winter at Clark, or find some other place that offers it. Otherwise, you won't be able to take certain third-year classes at WSU. Locked out of the survey. Shouldn't have locked anybody out. So I don't know why I did that. But yeah, 215 is only in person. Now I'm planning to record them and post lectures, and if the technology will support it, I'm planning to Zoom from the classroom. So hopefully there's an option for people who can't come in person to be able to follow along as if it was a remote class. But I don't know if the technology will support that. In the past, I haven't been able to do internet from the STEM building, but they may have beefed up the internet since then. Someone asked, if we're going to get online options for most or all classes winter term. I think the plan is for more classes to be shifting back to in-person in winter. So for engineering, we're trying to offer one section online, one section in person for the required courses. So 222 there'll be a remote and an in person. 223 in spring there'll be a remote and an in person. I think engineering 250 there should be a remote and an in person and so on. But I don't know about other departments. When does registration begin for winter quarter? Really, really soon, so check CTC link. You should be able to find your schedule there.
At the earliest, I believe it's probably the 9th. I'm on the 9th, and I've got the bullet of the credits.
Okay, cool. I didn't intend to put a deadline on the survey, but maybe I
The
did.
deadline was for the 29th.
Okay.
Yeah, like maybe before midnight on the 29th.
Oh, okay. I am not teaching engineering 270. I teach it in the summer, but for winter I do 222, 2 sections, and then 215 and 101. All right. Let's see. What else can I tell you? Find command. That's probably it. All right. So other questions? All right. Let's talk about the dreaded char star star. And let's see what this really means. And I want to use GDB to help us understand this, but I also want to use this to help us explore GDB. So let's draw a picture of memory, and this is going to be a totally bogus memory map, but let's just pretend. That this is what our memory looks like. All right, so fictitious memory map. Let me draw a few more up here. All right. And let's suppose you're the compiler and you're compiling a program and it says integer I. Alright, you and the linker work together and somehow decide where in memory are we going to store this variable I. Let me do a character. So we'll keep everything 1 byte. You're going to do a character C. Okay, you need one memory location to store this because it takes a single byte. And maybe you decide, no, I'm going to store that at location 2. So C is going to be stored right here. Alright, anytime somebody tries to do something with a variable named C, the assembly language code will say, we're going to use location 2. So if I say print the value of C, the print function will go to memory location 2, read the bit pattern in there, and use that to form a character and display that on standard out. Alright, so plain old variables are pretty straightforward. The computer, the compiler, makes a decision where will this variable be stored in memory, and then anytime you want to do something with that variable, it does it with that location in memory. Alright, so when you say char star s, now s is a string. So s itself has to be stored somewhere, and maybe it's stored right here. So at location 4 in memory, we're going to store the value of s. But the value of s is a pointer to a character. In other words, it's an address in memory. And so here it might store the value 100. And at location 100, we would find, you know, the first character of our array. So if our string or our character array contains the word hi, right, if s is equal to 4, then at location 4 we find the number 100, and 100 is where the first letter of that string is stored. So the first letter is H, the next location has the second letter I, and the next location has our null terminator saying that's the end of the string. And this is how any array in C works. Arrays of characters, arrays of ints, doesn't make any difference. So S is stored somewhere. I'm pretending it's stored at location 4, but if I were to print out the value of S, I wouldn't see the letter H. I'll see a number. That number is where that H is stored. Alright, so this gets one level removed when I say char star star argv. So argv is stored, I don't know, maybe at location 1. And it's equal to something like maybe 5,000. So at location 5,000, what do I find? I find a pointer to a character. And so maybe at location 5,000, I find the number 200. Alright, this is not the first character of argv bracket 0. This is a location in memory, and at that location, I find the first character of argv. And the second character is going to be in the next location, and so on. Alright, if argv is stored here and it's got a value of 5,000, it means at location 5,000 I find the address of the first string, right? The address where that first character is stored in argv bracket 0. And then at the next location in memory, maybe here's 224, that's the location in memory where argv, that's the location where argv bracket 1 begins. So this is a spaghetti ball when you try to map it out, right? argv is sitting right here. This points to an array of pointers. This first entry points to where that first array is stored. The second entry points to where the second array is stored. And each of these successive locations, starting at 5,000, is an address in memory. At this address, I find the characters of argv bracket 0. At this next address, I'll find the characters of argv bracket 1. Alright, so what I want to do tomorrow is I want to go into GDB and I want to run something with a char star star and see what this actually looks like in an actual memory map. And it's a lot of minutia and digging around, but it's well worth the effort, because this will give us a better understanding of this versus that versus this.
You
All
can
right.
almost think of it as like a two-dimensional array.
It is, yeah, exactly. And this is actually how we do two-dimensional arrays, but they're a little different from, like, you know, sort of other programming languages, 2D arrays. But yeah, this is exactly the way to think about it. 2D array of characters. Alright, go ahead and send me an attendance note on the way out. Yes, ODP 415 has a single test, so if you get 10 out of 10, you're good. Alright, have a good one. I will see you tomorrow.
See you tomorrow.